Okay, so I'm gonna go ahead and start talking. Um, Hello. I hope everybody had a wonderful weekend. I hope everybody's loving this cold front. I know I am. Um, a few kind of things before we get started with today's lectures. If you are in the need for new computer accessories, whether that be PC or Mac, if you haven't checked your email and you haven't seen 800 of these yet, um, they are having a spooktacular virtual sale from 9 a.m. to 4 p.m. October 26th, so starting yesterday through the 30th, for the SAC Tech Store, which is kind of the provider for all the tech stuff for the district. But they've got some really good sales going on. They've got some, like I said, open box models that were used as floor models, customer returns, things that had seals broken. So they're all really good. They make sure that they're actually working and like they're supposed to be before they give them to you. So, yeah. That's also where, by the way, if you're having computer problems, part of the tech store at SAC, like what they do is they do student repairs as well as professor repairs. So, um, it's a good thing. They've got a PDF list that will actually show you like the pricing and everything, but you can also just come to the SAC Tech Store and this website is fine and you're not actually on the system. But so yeah, so it'll say that it's offline, but it'll have all sorts of stuff that you can actually do and yeah. So, Tech Store. Tech Store is awesome. It's got some pretty cool stuff. So yeah. And it's got to spin the wheel so that you can actually do a prize thing. Um, yeah, yeah. So if you're needing new stuff, that's great. If you're not, then yeah. Yeah. If you ever wanted to know what Asus looks like for me, it looks like what you guys have. Only I get like 800 more tabs. Um, so the other thing is that early voting ends on Friday. So if you haven't voted yet, my suggestion is early voting because you can vote anywhere. You can vote anywhere. Whereas once actual election day comes, you can only vote in your designated district polling places. So, which may or may not match where your current location is. Um, yeah, yeah. So that's just a thing. Voting is important. Voting is extremely important, especially right now in this scary, scary world. Okay, so about class stuff. Technically, from this date, you have just about a month before your playtest is due. So this is the November calendar. So basically, if it lets me scroll down, cool. If it doesn't let me scroll down, what's your deal? Okay, fine. Yeah, so your playtests are due on the 30th for your game, so you have just about a month. Um, yeah, again, I've shown you this before. The calendar is great because you can see every little thing that's due. Also, starting next week, we're back up to game checks. So, I'm going to be asking for progress reports for what you're doing, how you're doing, things like that. That being said, I'm going to try and keep the things that I'm lecturing on simpler so that you have more time to work on your games in class, in quotation marks, since, yeah, we're not technically here. So, this week we're talking about uh, making your character move and how to get animations. Basically, we're not talking about, because animations work exactly the same as they did in 2D. So, like, how to trigger them, how to make them work, how to use the animator, all that's the same. Exactly the same. So, what the animation discussion is going to be about is going to be about importing and working with animations and talking about things like root motion. Um, and because depending on where you get animations from, depends on whether they come in as, separate animation files or if they come in as one timeline. And you work with them slightly differently. So that's what this week's lectures are going to be about, and we're going to do them on 2 days. We're going to do walking character control today, and then we're going to do importing animations on Thursday. And then next week we'll be talking about ProBuilder and terrain. I think we're talking about ProBuilder and terrain next week. We're talking about ProBuilder and terrain and ProGrids and Polybrush. Again, I've made this clear before. The second half of the semester, what I tend to do is I tend to focus more on tools that are going to make your life easier, whereas the first is kind of getting you used to the basic coding. If there is anything coding related that you need me to go over, you want me to talk about, etc., message me. There's more than enough time. I can throw together either a small lecture or I can throw together a video that would be 100% on everybody's own time. Yeah, I'm all for that. If you tell me what you guys need me to go over, or if you need something you're like, yeah, I know you went over this, but I don't really get it, let me know. I'm more than happy to re-lecture on it. I know that a lot of you are like floundering about code and trying to figure out, how would I code this? How would I code that? Ask. Ask and you shall receive. Basically, that's what this is. And the reason why I do the second half with more of the tools kind of side is because a lot of you aren't programmers. So the reality is if you're a programmer, you're going to be doing tons of research on your own anyways and figuring out how to program and how to do this and that and t'other. And you're going to program the games. If you're production or an artist, there's a bigger chance that you're going to need to use the tools or figure out how to get things into the engine or how to manipulate the engine to get it to work the way you want it to before code goes in. So I want to show you all these tips and tricks that make your life easier and then make it easier for programmers to program on top of it. So that's kind of the reasoning behind it. But yeah, so we're doing walking, character controlling today, animation on Thursday. Next week we'll do ProBuilder, ProGrids, and Polybrush on Tuesday, and terrain on Thursday, I think. We may do terrain. It depends. It depends on how fast we get through stuff. And then we'll talk about lighting, shading, and materials, which is a big whammy. And then we'll talk about NavMesh and AI. And this is one that a lot of you guys are probably using. I may switch this around and I may put NavMesh here. But I'm not quite sure. If you guys have opinions, give me a message, send me info. It kind of just depends on how you want to do it. And then Thanksgiving week will be 100% optional. I'm not going to lecture, so because I know half of you aren't going to be in any mood to lecture, or you're going to be traveling home, or you're going to be, if you're retail workers, freaking out over your store deciding that they're going to do Black Friday on Wednesday and that they're going to actually do Black Friday. I've got a couple friends and everything, especially since the mask mandate for Texas is technically ending November 4th, so it's like, okay, so now we no longer have a social distancing mandate. How are we going to control social distancing? How are we not going to have 500 people in a store? So, so that'll be kind of on your own. I'll talk a little bit about additive finishing touches, or I'll record this, I don't know yet. But that's basically it. You're going to have work weeks and a final day. So, not too much more, guys. We're almost done. Almost done. We're we've got a few more weeks. But, yeah, so it's not that far done. Or not that far away. Okay, so, before I get into anything, are there any questions about registration, next semester, anything else that needs to be brought up that's not related to, like, lecture? Alright, so I've graded pretty much every task list I've had. I've graded if I can get to it. If you've turned it in and you don't have a grade, check the assignment. There's a good chance I put a comment that's like, hey, this is private, I can't see it. I also have graded everybody who has turned in their, everybody as of this morning or late last night, that had turned in their postmortems. Again, there's a good chance I may have left you a comment if your grade seems a little bit lower than you thought it was going to be. And like a lot of you, I gave points off for grammar or formatting issues. Some of you decided to make bullet point lists or not even that, and I gave you a lower score. And I told you, if you want to resubmit it, and I'll give you a better grade. And that goes for anybody. If you're not satisfied with what I gave you, 100%, if it's still open, resubmit it. And like I'll get the resubmission, like it'll ding me, and I can redo your grade. Because, yeah, it was an essay, and I take it seriously. I take grammar seriously. I take formatting seriously. I was a little lax with the MLA thing because I don't 100% care, but, you know, paragraphs needed to be paragraphs. There needed to be indents. Commas needed to exist. Semicolons, periods, capitalization. So, yeah. Spelling. Spelling is a big one. And especially since you have computers. And I gave you the WAC lab. I told you about the WAC lab. They could have helped you. Nobody took me up on that offer. So yeah. But again, I think I'm pretty fair when it comes to grading, or easy. I don't know. So, okay. So with that all said, let's go ahead and talk about controllers. Again, you're going to start seeing these that say like Spring 2020 lecture. So I left the lectures from the previous year in here if you guys want to just watch those and fast forward through them. Some weeks have them, some weeks don't. So again, I have provided you with 2 scripts. One is for using a character controller, one is for using a rigid body. And we'll talk about the difference between those in a minute. I just want to make sure that you guys see this, as I've said previously. So the character controller one has a bad jump ground check in it. And this is actually the one that I'm going to demo today because I'm going to show you why it's a bad ground check. Why this doesn't work. Because it's a built-in function, and so you think, awesome, Unity built it in for us, it must work great. The reality is, no, it doesn't. So we have to kind of make our own. That being said, the rigid body one does have a pretty relatively good jump in it and a good ground check. And it's just a few lines that you delete the ground and jump check out of here, and you put what's in here into here. Yeah. And then this article right here is probably one of my more favorite versions of, because it talks about it really well, about the difference between the character controller and the rigid body. And it's kind of how I built my tutorial for this, or how I built the demo for this one. I kind of built it off of how they do theirs, because when I was researching the best way to teach you guys the difference, I found their stuff and I was like, oh, well, yeah, this makes perfect sense. Why reinvent the wheel? So again, it's written. I saw that a lot of you guys don't like written tutorials. I'm sorry, lots of them exist. Honestly, I would rather have a written tutorial, but I understand why visual tutorials work better for y'all. And the reason why I picked the Jaunted Haunt is because it's detailed, because it kind of shows you everything in one foul swoop without you having to do 900 hours of work to get a game actually done. It's it's one of my favorite intro kind of tutorials for 3D or for any kind of Unity development, because it's written well and pretty nicely. Yeah, exactly. That's my opinion. The idea that videos are nice, but that written stuff tends to get to the point faster. Yeah, that's kind of my whole thing. So, but again, I know I come from a different perspective because, again, I've got degrees in literature. I did all of that stuff, so reading for me is like breathing, even though I don't like it. So, yeah. Okay, so this is the PDF we're using. And it will walk you through. You technically are not going to have to do most of this, because the assignment for this week actually doesn't have you turn in your working assignment, or like your working scene. all it has you do, it asks you to create and to look at how these work. But all you're going to have to do is submit to me writing. You're just going to have to write about 250 words on how each of them works, which means that you do have to either watch this video or read through the last assignment, and what you think is going to be more beneficial for the game. Or for your game. And for some of you that may be like, neither of these are going to work for my game. And that's fine. That's fine too. There are a few of them that will probably find that. But yeah. Okay, so with that said, I have that on that screen. So again, I have one already kind of started and open. And the wizard mesh is there for you guys to use. It's this guy right here, if you guys want to. Otherwise, you can just shove a capsule or a cube or whatever you want in there. So the written tutorial that I have, that's the PDF, talks about how to make stairs and stuff like that. It's really, really easy. All you're going to do is you're going to go to Game Object, or you can right click here if you want, and 3D Object, and you're going to just use a cube. You can zero it out, and then you can change it wherever you need it to go. You can change the color on it. You can do whatever you want. But basically, we're just making shallow stairs. And one of the best tips here, I talked about this a little bit last week, was this idea that even though we're in 3D and we're in like a perspective mode, we can switch to either orthographic, which still doesn't look quite right, or we can come up here and say, hey, 2D mode, and we suddenly have a 2D cube that's a lot easier to work with. So we can say, yeah, I want the stair to be like that, and then Control D to duplicate, W to get your move tools, and remember, we can still use V, and we can still snap. So, you know, maybe we want that, and maybe we grab them both, we duplicate, and again, we V, and we kind of snap that way, and then we move across. So you can 100% make your stairs how you want. And then once you want to get back out of here, you know, because even if you press the Alt key to try and rotate, it's not going to do anything. Once you press 2D, when you hold the Alt key, it'll change to an eyeball, and you left click, you can do your rotating. So for those of y'all used to Maya, this is going to work a lot like, again, I've said this multiple times, it works a lot like Maya. So we can, you know, we can take our stairs, and we can, the R key is for scaling, we can make them wider, we can do however we want. And basically what I've done with these stairs that already exist is that they're, each of them, if you'll notice, already has a box collider on them, because 3D kind of recognizes that you're going to want box colliders on everything, so they automatically get a box collider. So basically all I did was I grabbed the stairs and I put them into one of them. So now they're just one object, which makes life nice. And then for this guy, it's just a cube that's been flattened the crap out and rotated. You can see the scale here, you can see the rotate here. And that's it. Now, you can put these wherever you want to put them. It just kind of depends on how you want to set up your level. Like, you may want to actually do this a little bit differently. It just kind of depends on how you want. And you're always going to want to check in game to see how it's going to look, so that you can actually see what you're doing. So as it is right now, if we press play, I can show you what this guy is going to do. So he moves around, the camera's stationary, he can jump very long distances. And you're going to see there's a couple places where I've pressed the spacebar and it just doesn't do anything. That's part of the issue with the character controller jumping. So, yeah. Well, it's not so much the character controlling, it's the grounded function that's attached with the character controller. So basically, this is all we're doing. We're just making this dude do his thing. Not anything groundbreaking or anything like that, but it's going to get you guys to understand how this works and how similar this is to 2D. Because it's really not that far off, except that we've got a few new functions and names. Yeah, so it's not that far off. Okay, so in this case, I am just going to duplicate him, remove component, remove component. I don't know why I did that. I should have just pulled him from here. Okay, so let's do it the other way. So, you know, we've got our model. We've added him in. It's this guy right here. And the way that we always do, like, again, because he has no animations on him, we can say, hey, I don't want to import the animations. If you have a material, you can put a material on him. If you don't, you don't have to. You can actually force a material. So this material that I have made, I can shove onto him and apply. Not that you're going to see any difference. He may be a little shiny. But so we're just going to grab this wizard and we'll drag him up here. And depending on how things are, depends on whether he comes in the floor or where he comes in at. So because of the way that this is set, and you can see wizard mesh, he's not quite where he should be. If you click the 3 little dots next to here and click reset, it'll reset him back to 0, 0, which is down here. So again, I'm just going to take the 2D and put him, and I'm going to put him slightly above, only because if you accidentally have things intersecting when it comes to either your rigid body or your character controller with another collider, occasionally physics go wacky. So just gonna have him, you know, up to where you want him to be, and it doesn't really matter. So yeah, so I can switch out of 2D. We have this guy. Everything's hunky-dory. And then the other thing that I've done is I've gone in and I've moved the camera so that I can see everything I want to see. Just so that I know, you know, that that's where I want the camera to be. And again, in an ideal world, maybe we would have the camera following the player, or it in a better location, because it's not in a great location, let's be real. But for what this is, this works. Yeah, for what this is, this works. And the same as we did in 2D, you can, you know, attach the camera to the player, you can attach the camera to, or you can set up Cinemachine to do a follow player. You can do a ton of stuff with Cinemachine in 3D, actually. So, camera choices are great, and they're up to you. So, I'm going to show you how to do the character controller, because the character controller is one that you guys haven't used yet. You may have seen, if you were looking for character controllers or for how to move your character in 2D, you may have seen like Bracky's tutorial, which had a character controller in quotation marks, but that's not a built-in one. That's one that he created for an add-on. Whereas Unity actually has a character controller built in for 3D objects. So that's the one I'm going to show you, and then I'm going to let you guys follow. Like I said, I have that tutorial, or you can just, you know, slap the script on and say it's done. So I'm going to let you guys do the rigid body one on your own, but they're not going to be that much different. Again, and it's not going to be much different from what we saw in 2D. So the character controller is going to be a little bit weird, and that's because it's not something that exists naturally in the 2D world. So we have our character in, and we're just going to click add component, and like everything else, we're going to start writing character, and there it is, character controller. Now it's going to say, okay, we've got slope limit, step offset, skin width. Like, these words all seem a little weird to you, I'm sure, because they seem a little weird to me. especially on first blush. So you're going to notice the first thing is that your character comes in with a capsule collider already attached to it. That's kind of nice, right? So first thing that I always do is I always say, hey, well, you know, maybe I need to figure out how I'm gonna like fix some things. And you don't actually manipulate the actual collider like you normally would. Like normally we would see a collider actually on here. It has to do with this radius and height. So those are actually what you have to do. So this time you have to slide. And you can write your number in, or if you hover over the name, you'll get a little arrow, a double-sided arrow, and you can click and drag back and forth to get it skinnier or taller. And then you can adjust the height, and the center, that's his center of mass, so you can move it down if you want to move it down a little bit. So you just want to get it, you know, approximate. And that's going to mean, you know, things can actually collide into the hat, a little bit into the bottom of this robe, some into his face, but maybe we move it, you know, that's not the way it's... So maybe we move a little bit that way. So yeah, so that's how you control these last three buttons. That's how you control your capsule collider. So that's what that's for. So again, that's pretty similar to what we've seen in the past, except generally you have the edit collider button. And again, you can attach more colliders, more triggers, more everything to your character. Like if we wanted to do it, if we wanted to add colliders to each of like his hands, his eyebrows are technically separate so that he could have an animated face. Yeah. He's from a defunct, in case anybody's curious, he's from a defunct project that no longer exists. Yeah. I think it got killed, if I remember right. So, what are these top buttons? Because those are the next ones. Slope, step, skin, minimum move distance. So, the slope limit has to do with how steep of a slope your character can traverse. So, at this point, it can walk up a 45-degree angle, but if we wanted to, we could make that slope smaller or bigger, depending on how much of an angle you want it to be. And yeah, and you're going to see, if you hover over it, it's also going to tell you that it can be between 0 and 180. So, do you want it to be a goat that can literally go vertically or backwards? Then 180. Otherwise, smaller. So, step offset, meanwhile, has to do with kind of how much of an offset the step has. So, for every step taken, how much kind of does it offset or move? And then the same thing, skin width has to do with how wide your skin is. For those of you who are 3D animation people, yeah, it's about the skin and the movement in the skin and rigging. So we generally won't, or at least for him especially, we won't worry about it. And the minimum move distance is, so for any movement made, how much can he, at the smallest point, move forward, or left or right. That's all those mean. So they're pretty self-explanatory, to be entirely honest, which is kind of cool. So, something to note though, if you come into, oh, where is it hidden nowadays? Project settings. If you come into here, previously you guys have used Physics 2D. We're now in a new engine. We're in a physics engine. Whereas Physics 2D, and you're going to see this with your rigid bodies, but I'm going to bring this up here because it does sort of affect your character controller, sort of, asterisk mark. Because the big difference between rigid body and character controller is that the character controller, while it does adhere to collisions, it doesn't use physics. So it doesn't push, it doesn't pull, it doesn't do that kind of stuff. So you actually have to like code in drag or force gravity and things like that. But for your rigid body and even for other things, for the 2D world, we were able to put new gravity on everything. Like, we were able to say, yeah, that's got this much gravity, yeah, this has this much gravity. For physics, however, in the 3D world, you have a master controller, and you do in 2D, but it really isn't adhered to. It's like, we don't care about that. For 3D, it really cares about this. So this is in your project settings. So if you want to make your world heavier overall, this is the best place to do it. That's the best place to do it. This is also where you're going to find defaults for things like bounce. So if you have a ball game or velocity, there's a few other things inside of here that you may find yourself wanting to use. And the place I linked will talk a little bit about this kind of things, but this is also if you don't want things to collide with certain things. So say we don't want the UI to collide or the ground to collide with water, we could take that off. We could take water not colliding with the ground, so we would just do that. And that's a great way. That's something else that's really, really helpful. But yeah. So once we have our character controller on, unfortunately, it's not just that simple. We do have to code. And this is going to be the one place where we're going to code the most, probably this whole half of the semester. Again, it's kind of the same way as the first half of the semester. Getting your character to move is definitely the biggest event of the season, more or less. So I'm going to create a new script. You see, I've already got scripts in here, but I'll create a new one. Create C# script, player movement, fall 2020. Again, name it something that makes sense to you. I tell you guys to call it player movement, but maybe that's not what you want to call it, or you don't care enough to call it anything. You do you, booze, you do you. So we double click to open Visual Studios. Visual Studios decides whether it's going to actually open or not. Maybe. Maybe not. Okay. So, and you're going to see, this looks exactly like a 2D game script. Nothing has changed here. This is all the normal stuff. The name, the start, the update. We can use fixed update. Like I said, the only big thing that changes is that instead of on collision enter 2D, it's just on collision enter. And instead of on trigger 2D, it's on trigger. Like, that's going to be the biggest changes you're going to see. Plus the addition of a z-axis. So we're going to use, when we use vectors, we're going to use vector 3s more than we're going to use vector 2s. So let's get started. The first thing we have to do is we have to say, hey, I want to access my character controller. Like, that makes sense, right? Well, okay. Let's take a couple steps back. Because character controllers are cool, because they've got actual move functions built into them, so you don't have to actually, like, program exactly how each thing works to move. Now, the issue with that is that they have two different versions. They have move, and they have simple move. So simple move accounts for gravity, so it uses gravity. However, it doesn't let you affect the y-axis velocity, so the falling velocity or speed. It's just, hey, gravity exists and deal with it. Which is, it's not so great when you're trying to jump. When you're trying to force your character to go upwards, and it's like, nah, you can't have extra up velocity. You can only have gravity. Gravity is the only thing. Jumping is a pain in the ass. So, the better one to have, if you are using jumping, is that you use move. The problem with move is that it basically has nothing else included in it. So, you have to write more code. But it means you can get a jump. Again, remember, I am showing you the way that the jump is set up, or grounded is set up inside of the character controller inside of 3D World. However, the grounded function doesn't work the best. So basically, this is why you shouldn't use it. The actual coding for the jump, the actual coding for the movement, all of that is great. The grounded function, however, is not great. The one that's in the rigid body code that I provide you guys, or the way that they do it inside of the tutorial that I linked, so the article that I linked, the way that they do it, which uses raycasting, is the far superior and less aggravating way to do it. But I wanted to show you how to do it the wrong way, so that you know that it's the wrong way, and you know why it's the wrong way. Or why it's the way that Unity says it should work, but then they don't actually support it, so it doesn't work. Yeah. Okay, so yeah, we're going to use the move function that's built in with our character controller, because it lets you code everything and it lets you jump really easily. So we need to create some sort of reference to the character controller component that we put on our character. In the past, we've done it where we've done a public and then we've dragged the character controller into that area. And that's fine if you want to do it that way, but we can also do it private because we don't really need it public. I had you guys do a lot of public things just because it was easier to understand where everything was. So we're going to say private, and then we're going to say, hey, I want the character controller. So that's the type, and I'm going to call it something. Let's call it charConf. You know, so that's how we set that up. But now it's like, hey, I don't know what this is, and I can't find it. So how do I make sure that I can find it? Well, we have to make a reference to it. So we have to say charConf in our start. So as soon as everything comes up with this script and the object is created, it's happy, the scene has started, the first thing it does is say, hey, so let me get this component so I can work with it before we get to update. So charConf equals get component, and then you're going to do those greater than, less than, side carets, however you want to call it, and we're just going to say we want to get the component that's called the character controller. No, we want to get the component called the character controller. And that's how we get access to the character controller. That's it. Relatively easy, not too bad. Now, we know that we're going to have the character controller and that that's going to move it the same way that we would access the rigid body when we were in 2D. We want to access this character controller because that's how we actually control movement. So, just like with how we did character movement in 2D, we want to have some sort of access to speed. We want to do speed. So, if in this case, we're going to do public, and I'm going to do a float, and we're going to call it speed because that's what it is. And I'm going to go ahead and just set it up here, and we're going to say 10F. Remember that if you use a float, it has to have this F after it. Otherwise, it's like, that's not actually a float. Nah, like, if we get rid of that F, it's going to throw an error, or it should throw an error. It's not going to throw an error. Sometimes it's smart enough, sometimes it's not. But, like, if you hovered over it, you're going to see it says, hey, that's an int32, whereas that's a float. So, F is your best friend. It may get angry at a different point if we did it that way. Float and F. So, now we have access, and the reason why we do this one public is so that we can access it in the inspector and edit it as we need to. Again, we could make it serialized or a protected private. There's a lot of different ways that we could access it and change it, but this gives us the easiest and best way to do it. And Unity has enough protection built in that, you know, if somebody's going to want to hack into your game, and first off, do they really want to hack into your game to manipulate the speed, then they're going to do it, whether it's public or not. So, public makes it easy for you to use, makes it easy for any of the other people who you are working with to use. Yeah. basically, if you want something that more people can manipulate, public. If you want something that nobody else can touch, that's when you serialize or privatize or things like that. So yeah, so now we've got our character controller, we have our speed. I'm going to go ahead and save this because my computer's been having an issue with deciding to, like, get angry. Now, the next thing we have to do is we have to tell it to move, right? We've got our speed, we've got our thing, and we have to say, hey, apply this speed to whichever direction I'm going. So, inside of update, again, remember, because we're not using physics, we don't have to use fixed update, we can just use normal update. We're going to say vector 3, because we have 3 directions or 3 axes that we have to worry about nowadays. And we're going to just call it move. So we're going to say, hey, move the stuff. And how do you want to move it? We want to move it by creating a new vector 3 that takes our input, and we're going to just use get axis here. We could use get axis raw if you wanted to, but we're just going to use get axis. And we're going to say horizontal, because hey, we want to move horizontally along the horizontal axis. Remember, that's the X. Now, remember we talked about the big difference between 2D and 3D is how we have 3 axes. And again, we talked about in some programs, up and down, so like a jump, is on the y-axis. Sometimes it's on the z-axis. In Unity World, up and down is y. So when we're moving, and right now we're just talking about moving, we don't want any input on our y-axis. So we can just say 0. And then the other way that we want to move is we want to move on the depth. So if we're looking down at like a board, we want to be able to move in the depth and in the X. And we don't want to be able to move up and down. So for this one, input.getAxis vertical. And this is where that gets confusing, because you're like, hey, wait a minute, but we talked about verticality with the y-axis. So yes, but the way that your inputs work, your inputs, remember, horizontal input is like your up key, your W key, your joystick pushing up. Whereas your horizontal, which I think I just said, your horizontal is going to be your AD, left, right, joystick left and right. So technically we don't want to control yet, because our y-axis would be our jump. That would be when we're getting physical verticality, but not when we're pressing a button that we call vertical. And that's probably, honestly, the most confusing line ever. And that's just because of the way that our brains think. And you could, yeah, go in and change the names of these in the player settings, but is it really worth it in the long run? No. So then we have to apply. We have to say, yeah, we're moving in these directions. What are we doing with that movement? How do we do it? Well, remember how I said that there's this wonderful move function? We just call the move function. So we say, hey, Characon, we want to access, because you're a character controller, you have a function called move. So we want to access that function, which already tells us how to move, and we just want to use whatever this vector 3 has told us. We want to multiply that by time dot delta time. Remember, that's like to make sure that things are moving the correct speed rather than going every frame. And then we want to multiply that by our speed. Cool. So now we basically have a character that sort of moves, right? We could save it and maybe see a little bit of movement. So if we come over, we save it, and I haven't done anything wrong, which we all know happens. We're just going to attach this onto our wizard mesh. And if we come over here, we're going to see, hey, yeah, we've got our speed, we have our player movement, so let's click the play button. And he's moving. He's floating in midair, and he's not, you know, turning to follow the point that the arrows are going, but he's moving. So maybe that's all you need. Maybe you have a ball or something that doesn't have any directions, and you can see he went up those stairs, but oh, now he's up in the air and he's not coming down. Because we haven't told anything to affect gravity. Like I said, move, whereas simple move looks at gravity, move is like, gravity, what's that? So let's deal with him actually looking the correct directions. And this might be different depending on how you want to do it, but the way we're going to do it is that if we press the W key, he's moving that way. If we press the A key or the S key, he's going to face like towards the bottom of my screen. If we press the D key, he's going to look towards the stairs. And if he presses the A key, he's going to look away from the stairs. And again, you could easily maybe attach a camera to the back of him to get him to follow that kind of movement. But yeah, so see, movement is easy. Like, getting this character controller to move, not so bad, right? Now we just have to worry about getting it to work a little bit better. So back in here, we have to say, you know, how exactly do we want it to move? Like, hold on, sorry. I'll be right back. My doorbell is ringing. Okay, I'm back. Okay, so we wanted to basically, you know, do things and turn. It's an easy fix. It's basically a couple lines of code. And we're going to put this right at the top of update. You can put it below this code, but I like putting it above. So all we're going to say is, hey, if move is not equal to vector 3.0, oop, that's not right. Okay, if move is not equal to... Why are you angry? Yeah, it's declared. That's the whole reason why we're doing this. Oh, it's not declared yet. Okay. What did I just do? Oh, I'm lying. This goes down here. So, after our movement, check if we're not moving or if the 0 has happened. And then you want to transform what is considered forward into whatever direction move has happened to be in. So, as long as move is actually moving, transform what you say is forward into the direction that move has happened. So if we save this and we minimize and there's no errors or crashes, when we click the play button, we're going to see now he moves in the direction that our keys are pressed. Easy, right? Simple. Another thing that's basically like 1-2 lines of code. A lot more simple than writing this for a 2D movement script. So not bad. Not bad. Honestly, to be entirely honest, 3D tends to have a lot more bells and whistles because Unity was created as a 3D engine before it started realizing that people wanted to use it as a 2D engine. So as a result, 3D tends to work a little bit better. It's had a longer run. It's happier. That kind of stuff. 2D works great. And it's a great place to start because you guys kind of get thrown in the middle of everything and are forced to figure it out. Like an immersion program. And then we take you to a different part that has a different dialect. So everything works the same, but it's a little bit different. But yeah, so 3D tends to be more streamlined like this. So now that we've got it looking in the right direction that we want it to, the new thing that we've got to worry about is the fact that, remember, we've got that whole, we're not falling when we go up the stairs, or when we go up the ramp. We're now suddenly floating. If we come over here, we can probably see it better. We can see that we're now, you know, floating above everything. So we've got to get gravity to actually work. So first off, we got to get him to fall to the ground when things start. And then second off, we have to get him to actually fall when he goes over the edge of the stairs or over the edge of the ramp. So to do that, again, it's not super bad. We're going to add a new variable in here, and we're going to go ahead and make it public because there's a chance that you might want to change like how much gravity is. So we're going to call it gravity, and we're going to equal it to negative 9.81. And that's Earth's gravity. Earth's gravity is right around 9.81, so negative 9.81. So, you know, if you're doing something that's meant to be set somewhere else, or underwater, or things like that, there's a good chance that you're going to have a different gravity set. So making this public lets you affect it and see how that's going to affect your game. And while we would love for things to translate like 1-to-1, so like, yeah, gravity in the real world is negative 9.81, so in our game it should be negative 9.81. The reality is that a lot of times you end up tweaking your gravity variable to make it seem more real. So your gravity ends up being something completely different than negative 9.81, just because that's the way that simulation works. So don't feel like you have to adhere to real world kind of things. Yeah, that's basically my spiel on that. So now that we have that, and again, remember that the reason why we're doing this is because we're using this move function. If we used simple move, gravity would exist and we wouldn't have to worry about it. But it wouldn't let us jump. So if you don't have a jump, simple move may be your best friend. But if you need to jump, then move is definitely your best friend. So we do this, but there's another way that you could do it. You could access the universal gravity function variable that's inside of Unity. But again, it means that you can't manipulate it if you need to manipulate it. So I'd rather just do this. It's not that bad. So the next thing we're going to also do is we're going to talk about the fact that we need a character velocity so that we can have that Y velocity, because this sets our velocity. This sets everything we need to know for when we're moving. However, when it comes to the y direction, when it comes to jumping, we need to understand how to use that velocity, or we have to create our own. So we're going to call it private, and then we're going to do vector 3, and I'm going to call it car velocity. So it's just a vector 3 again. So how is the velocity working in each of the axes? And we're definitely going to access this more when we're talking about the y variable. And it's going to be pretty relatively easy again. You're going to come down to the end of your update. And this is going to be the one place where we're not going to have to like set a private variable inside of start. We're going to set it inside of update. Inside of update. So below everything, we're going to say, hey, the car velocity dot y. So the y value in our velocity, or in our vector 3, and then we're going to add to it gravity times time dot delta time. And basically that's going to say for every step we take, make sure that the y velocity is pushing us down. And then at the end here, we're going to say, yep, we got to actually apply that. So we're going to use that move function again, and we're going to say car velocity times time dot delta time. So now our character has gravity. Now if we come in and we play it, we're going to still see some problems with it. But you're going to see he fell. Yay, he's on the ground. Everything's working. He's going to feel a little clunky. And the biggest reason why is because we're constantly adding gravity. For every update, we're adding gravity. And so there's more and more gravity. And eventually, because they're getting more and more, that number's getting bigger and bigger and bigger, he'll actually fall through the floor eventually because of the way that our physics works. Or our not physics works. But yeah, if we were to print it out, and you can see he kind of just looks a little clunky, like he gets to the end and it's like automatically to the floor. So we have to fix that a little bit. And to do that, to get it so that it's not automatically adding, and we can see that if you really want to, we can say debug.log char velocity.y. And if we come in here and we play, we're going to see that it's going to see how it's getting bigger and bigger and bigger every single time. And really, the only thing we want is we want this to be bigger if we're falling. Like, because we want to have that velocity going down further. But otherwise, when we're just walking around, we just need it to be negative 9.81. And because it's doing this number's getting bigger and bigger and bigger, eventually this would also bog down your game. And that's because the bigger a number is, the more it takes up in storage. So eventually it would cause problems. So to fix this, and it's an easy fix, it's a one line of code fix. Okay. It's a 2-line code. And basically all we need to do is we need to say, hey, if our character is already on the ground, we don't have to worry about changing that y velocity. We don't need to worry about adding that gravity in. But if he's not on the ground, we want to like progressively make that gravity bigger so that he actually has acceleration going downwards. Does that make sense? The idea that when you fall, you get faster and faster and faster until you splat to the ground. Okay. So that's kind of what we need to say. We need to say, hey, this is what we want to do. And this is where I am going to hazard and warn you guys. I'm going to show you the way that it's built in for you to use. However, the built-in is grounded function. It ain't that good, guys. It was something that everybody was so excited about, and it was so wonderful. And then we figured out it wasn't working like it was supposed to, and it was clunky and gross. And then Unity said they were going to fix it, and then Unity slowly took it off of its fix list and kind of let it die. But it exists, and I know you're going to find tutorials that use it. So I want to show you how to use it, and I want to show you why it's maybe not the best option to use. It makes it remarkably easy to code because you don't have to worry about calculating raycasts. But it's not your best option if you need a grounded check for jumping and for that kind of velocity fall. But basically, you'll be pretty close to this if you're talking about doing it with a raycast. It'll basically work the same way. You'll just write a function for checking grounded. And I'll show you how that will look at the end with the rigid body. But the article that I link will also walk you through exactly how to do it. So yeah, so at the beginning of your update, you can say, hey, if car caught, and like I said, it exists. So look, if you start typing is, it automatically pops this up for you. That is the function that it works okay. It doesn't work great, and it doesn't work all the time. And unlike the bunny jump, where when you kind of built the game, it basically worked okay, this does not work well when you build it. It just stays kind of broken. So if Carcon is grounded, and because we want to check and see if our velocity for the Y is greater or less than 0, because we want it to be, because we're at negative 9.81, so we want it to be, hey, if that negative 9, if it's at negative 9.81 or lower, let's just reset it back to 0 so that it can hit that negative 9.81 and just keep looping itself. So we say car velocity is less than car velocity.y is less than 0. And then we say, hey, car velocity dot y equals 0f. So, because a couple of you have asked, and I figure I will answer it here. Why do I do the curly brackets around if statements that are only going to have a single line? Because technically you don't have to do it. One, there's multiple reasons. One, it makes it easier to see what is attached to this if statement. This is so much easier to read than that. It really is. And when your eyes are tired, and it's 4 o'clock in the morning and you've been working for 2 days straight, you want everything to help you that you can. And it's not like your computer cares that there's extra lines there. It really doesn't. The other reason is that there's a good chance that eventually down the line I'm going to want to add more lines into those if statements because that's just how they work. And so the curly brackets mean I don't have to work harder later to add them in and to remember to add them in. So those are the two kind of the big reasons why I do that way. Is it wrong to have them without it if it's a single line? No. I have never commented and told you guys, that's bad coding, because it's not. But it definitely, this is much more aesthetically pleasing, easier to the eyes, and saves you a lot of trouble down the line, especially when you're debugging and trying to find what belongs to what loop. Especially if for whatever reason your tabbing gets all off, and so suddenly you're like having to figure out what belongs to what. Yeah. So basically, what this is saying is, you know, this resets your gravity for you. And the longer your fall is, the more your velocity will be allowed, so the more this will build up. But if you're grounded, it's just going to go, you know, grounded. Okay, so at the end of this loop, we're at negative 9.81. We come up to the next update. Oh, we're less than 0, so we're at negative 9.81. All right, set it back to 0, do our movement, and then apply our gravity again. And it's just going to loop and loop and loop. So it's just going to keep that feeling pretty smooth, if this worked like it was supposed to. It's going to keep it pretty smooth, but it's going to actually help you accelerate when you're falling. So, you may or may not be able to see a difference. There's a possibility that you won't be able to see a difference, or you're going to be like, I don't understand the difference. But I promise you it's there. So you see how he has a much gentler fall. And that's where you may want to make your gravity bigger at this point. But he has a much gentler, and it's even. Every time it's been the same. And you could also say, hey, you can only move in directions, like your arrow keys only work if you're grounded. And that would be another way, because right now you can move while you're falling, so, you know. Again, little things that you can tweak and make better however you want. So now let's add in a jump, because that's basically what we need to do, right? So again, we're going to add another public variable. Public, we're going to call it a float. And you're going to notice with 3D we do a lot of floats. Over ints we do more floats. And we're going to call it jump height. Because we're going to want to say, hey, how high can we actually jump? And to start with, because it's a pretty standard number, we're going to start with 2, because that's, like I said, pretty much any tutorial or anything you see will start you with a 2 or a 5 when it comes to speed or when it comes to jumping, things like that. So, there's a few different ways that you can do jumps. And like I say, if you're following along in the written version, I talk about the idea that you could use force, which is simple to code. It is very simple because you're just like, hey, add force, do this thing. But it requires a lot of guessing and testing to actually get it to work like you want it to. Or you can use the height way, which is a bit of math. It's math. You know. If you're not comfortable with the idea of doing a little bit of math and figuring out how you want this to be, then you can use force, which again the article shows you how to do both ways. So that's there for you guys as a really good reference. I'm going to show you kind of the other way. So jumping, and this hole is grounded. Is grounded only actually checks itself, like as far as being attached to the character controller when movement's happening. So if you take your finger off the key, it's not checking if you're grounded. It's only checking if grounded when things are happening, which is really, really bizarre to me. So you kind of have to add a couple new things to hopefully figure it out. And again, it doesn't work the best. So to do that, we add a new private. We do private bool ground check, and we're just going to set it equal to true because we're going to start out with being on the ground, which is technically not true, but we'll just go with it. And then at the beginning of everything, before we do this whole if car cont is grounded, reset this, we're going to add some more if statements. And what we're going to do is we're going to say, hey, if it's true, so all we have to say is carcont.is grounded. So if grounded actually exists, then ground check equals true. So basically, for the last check of is grounded, what does it equal? And we could do else false. We could do a bunch of different things. Some of you guys don't really understand those, as I have seen. So we could do if carcont.is grounded equals false. But the easiest way to do this, the single line way to do this, would be ground check equals carcont dot is grounded. Single line. But whichever way makes sense to you, use it. Like, that's one of the beauties of programming, is that you've got 100 different ways to do the same things over and over again. So whatever way works for you, use it. So, again, if you read along, I have a whole point of why does this work, or why does grounded not work like it's is grounded work like it's not supposed to. Who knows? Yeah. Like the patch, they said it was going to be patched, and then it was never patched, and then it got moved off the patch list, and so who knows? Who knows? So now we can create our convoluted jump down underneath before we reset the gravity. With our other movement, we can say, hey, if, and this is where our good friend input comes in, get button down, jump. Remember, that should be automatically set. If it's not, you can go into your project settings and find it. And then we want to say, hey, before we do anything, let's make sure that ground check is true. So you can say, hey, if ground check or if ground check equals true, whichever one works for you. And we're going to say car velocity dot y, and this is where our math comes in. It's such scary math. We're going to say, hey, add to our y velocity the square root, square roots, math f dot square root. And so basically this accesses the math library, and it accesses the function square root, and square root says, hey, the square root of what number? And we're going to say jump height. We're going to multiply it by negative 2f, and then multiply that by gravity, the gravity function that or the gravity variable that we built. So we know these two numbers, because they're both negative, will create a positive. And then this is a positive, so a positive times a positive will give us a positive number. So we go up. Now, when we save this, and we come over here, if I didn't do anything wrong, we're gonna be able to jump. There's a good probability. So you see, we can jump. But he doesn't always jump like he's supposed to, because things aren't being reset. So things aren't being reset, which is why it's not... I messed something up somewhere along the code. So he can jump at the beginning, but is grounded isn't being or ground check isn't being reset. Pretty sure that's what it is. Again, debug logs are your best friends. Okay, false, 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 true. Like you can see there's a few little weird places here where it's like popping true. And it will only let us jump when that's true. So again, is grounded is not your friend. Let's see. If we switch it back over to this guy. Yeah. It was literally the same thing, just old version. You're gonna see similar problems where you can kind of jump, but the jump doesn't always work. So again, is grounded is fickle as all get out. Not your friend. Not your friend. Period. The way that you can get around using is grounded. One, it talks about it in this article. And it'll talk about it down here. And basically what you're going to do, those of you who did the Haunted Jaunt, if you didn't do it, yes, it's closed, but I do suggest you looking through it because it's got a lot of really, really good points, and is really, really helpful. The big difference is, and the way that it adds, or what it does is... Okay. Okay, cool, that's fine. He can be pink the rest of the way. He's pink because there's a material missing. Okay, come back. Okay, so the big difference with the way that the other check works or the other jump works is that it does use a raycast. But basically what you do is you add a box or a sphere or an empty object, and in this case it's an empty object and it's just at the bottom of them. So like if we switch this over to 2D, you're going to see it's right at the bottom. It's right there. So see where it's right underneath him. We could actually take it up a little bit further. But you want it to be not quite like right at the bottom. You want it to be so that it actually kind of goes down. And it casts a ray. So it just says, hey, ping different rays off of this. And if I'm touching something that I have designated as ground, then I'm grounded. If not, then I'm not grounded. Like, revolutionary, right? And we can look at it inside of this. And again, I've provided you guys with a script for the rigid body as well as the working script for the controller. That's on this page. That's these two right here. This one is the character controller. This one is the RB, the rigid body. And it kind of tells you what you use. You're going to see this one has a lot more variables. But what this does is it takes the sphere, which is your check point, so that's my little thing at the bottom. It uses the transform of it, and then it creates this, which basically says create a variable called isGrounded, or not create because we have a boolean. So take isGrounded and use physics to check the sphere, check the position, check the distance, what is the layer that we have to check for, and then whether we ignore any kind of interactions. So you have to create a layer mask, which is basically just, hey, you know, what layer is things on, or what layer are things on. So like in this case, the stairs, it's on the ground layer. We can add all the layers we want and change all that kind of stuff. And yeah, so that's how that works. It's really simple. It's kind of a scary looking code, but you don't really have to know what it means. You just plop it in there and life is good. But again, the rigid body, it looks pretty similar to what we've done for 2D. Like, this one does, I do use AddForce. This one does use fixed update, but it checks your input in the update. But it's gonna look, you know, remarkably, it's gonna look similar to what we just did with the character controller, but it's also gonna look similar to what we did in 2D for rigid bodies. So, okay. Any questions? Concerns? Alright. I hear no from the Peanut Gallery. So, like I said, I'm going to let you guys kind of play around with the rigid body on your own. If you want to code and follow the way that they coded it in the article, be my guest. If you don't, and you just want to use the scripts that I provided you with, that's fine too. Because again, I'm not going to be checking that you actually wrote code here. I'm just going to be asking you guys to write a little bit about which ones you like better, which ones you don't like better. And the article actually goes into a really good discussion over kind of what the big differences are at the bottom, you know, after you get through all the coding that you guys hate seeing. So, collisions. Yeah, collisions can be the big difference. Rigid body's like super precise. Like, that's the whole point, because it's directly related to the physics engine. It's super precise when it comes to collisions. Character controller. Yeah, character controller is a little bit more friendly. Um, like, that's the big difference. Um, and then the other one is that the character controller is meant to be simple. It's if you don't need to have your character doing a lot of extra stuff, character controller is easy. It is ridiculously easy. If you don't need it to have physics interactions, if you don't need to, kick a Bible halfway across a room to summon the devil, I don't know, then maybe you don't need physics, so you don't need the rigid body. You just need to be able to, walk upstairs or go down a portal or things like that. Whereas rigid body, if you need to have that kind of physics functions, if you need to have things changing, yeah, not a problem. If you need to have more availability and more ability to change things on the fly, rigid body is going to be your best friend. Now, for those of you guys who are doing cars, you're going to want to look up car controllers. You're going to want to look up how they do that, because cars are notoriously difficult. They actually have their own collider set, so inside of Unity, you can actually add a component and you have wheel joints and wheel colliders specifically for cars. So, that's one I don't have a lot of experience with. I've done a couple of them, but every time it's just kind of like, is it really worth the effort? And then we decide to make things like flying cars instead. Yeah. Because, yeah. So, yeah. So, I mean, as far as if you ask me which one is my personal favorite or personal choice, if I don't need any physics functions, of course I'm going to use a character controller, because that's, like, simple. That's, looking at the code between them, you've got rigid body versus character controller. Like, character controller is much simpler. Not that this one's hard, it just requires a lot of extra stuff. But as far as what, like, my little studio uses, we tend to write our own character controller, we tend to write our own movement scripts, so we don't really use either, because we're using different kind of interaction sets. And you'll find that, like, even if you come to the Unity Asset Store, you're gonna find, if you type in, generally if you type in character controller, you're gonna find all sorts of people who have written different kinds of character controllers, an animal controller, things like that. And it's really, it's a big business, to be entirely honest, because it kind of depends on a lot of things and how you want to structure everything. So, and you'll see some of them, very few of them are free, but some of them are free, some of them are going to be animation packs. And really, you do the same thing that you did with 2D if you're wanting to do your animations. So you'll access your animator and you'll say, hey, if this button is pressed, do this animation, or set this parameter true so this animation plays, basically. So it's not going to be a lot of anything extra, really. It's the same code, it's just in 3D world instead of 2D world. So, and again, because some of you talked about this last time, you're like, I don't want to use anything from the asset store, blah, 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 blah. Y'all dumb. Use asset store stuff. use things that are free. Use things that you can find to your advantage, because make your life easier, especially if you're not an artist. Why are you needing to show art skills? If you're not a coder, why are you needing to show code skills? Like, yes, I do want you to write one code, one script that is all your own. And that can literally be, press this button to escape. But if you find other code or find a tutorial that works for you, do it, find it, use it. If you find assets, which are great, and you can find them from here, we'll talk about a few other places on Thursday. If you find particles and shaders, like, we talked about shaders a little bit. Shaders, like, change the way that they're, like, post-processing. And sometimes you want, like, an outline shader and things like that. But yeah, so find shaders that work for you. Find stuff that works for you that makes your game better. Because, yeah, I use this one actually quite a bit, which is an outline shader, which creates kind of an outline effect, which is really nice for things when you need them to have, like, that kind of outline. I think that's the one I use. I don't remember now. I think I ended up writing my own, or taking one of the ones that I found and writing on it. But, maybe you need to have something that does dissolving or things like that. You can create or get shaders that do it for you, because I am 100% not going to ask you or make you write your own shaders, because even for programmers that can be a thing. And on top of that, shaders aren't actually written in C++ or in C#. They're written in their own language. So that would be teaching you guys a whole nother language, or at least, and shaders in general for across most game engines and most places, they kind of have a similar language. But yeah, there's a couple of them that have been fighting for superiority. So if you find things that make your life better, you want to create toon shading, you want to do some matte cap shades, make your life easy. Find animations, find things for yourself. I would personally like you guys to make particles on your own, at least one particle that's yours. But, maybe you're going to find a really cool advanced rain system, or whatever you want to do. Okay. So, any questions about what you need to do on the assignment? What you need to do in the next coming? Can we add in? Yes! Yeah. We talked about that a little bit on Tuesday. We talked about that last week about, just chucking in your own models. 100%. Use your models, use your art, use whatever you have. You can use your own models, you can use your own animations, you can, whatever you want to do. It's your game. You do you guys. I was one of those people when I took this class way back when, where I made everything myself, including music, and, just about died. But, yeah. 100%. If you've got it, use it. Yeah, that's fine. 100%. I'm all about that. If you've got assignments that overlap or things that make sense to do for more than one class, I'm all happy with you submitting that for me as well as them. I did that quite a bit. Some professors don't like it, so it is always kind of a good idea to ask them if you can do that. Because some professors say that's cheating. I don't get it. Like, why make me do something twice? Yeah. Yeah. Like, I don't think I've got the animations up for it. that one. Where's it at? I don't think like I said, I don't think the animations are up on it, but for a lighting, shading, and texturing class, I kind of made the model, but I also made, it had animation, so like all this lit up, and everything worked. And that was specifically for another class that was all about getting mechanical, it was for a mechanical animation thing, and yeah, I got yelled at about, you know, using stuff from another assignment. But, you know, work smarter, not harder. Yeah, I really liked it. It made me happy. And it's all hand drawn exactly the way, because like we had to kind of dissect a game, whatever game we wanted to use, and so I used Borderlands, and we had to look at how they actually did their shaders and everything, and the answer was they didn't do shaders. Borderlands 2 didn't use a shader. They hand drew everything. So everything is base color. Everything is hand drawn in, which is kind of one of my specialties, doing all that kind of stuff. So yeah, it actually ended up this. Yeah, so like this ended up being one of the final renders for it. But I had to show, like, I had to prove to the professor because they didn't believe me, so I just showed them how it like all built up. Yeah. Yeah. It's fun. It's good. It's good. Like, and those are the maps. The cleaned up maps. Like, there's MIP mapping on all of them, but I had to have them clean so that they could see the edging and everything. So, yeah. Yeah. Yep. So fun. I did Bioshock as well, but that one wasn't quite as successful. But yeah. Okay. I used a mix of Illustrator and Substance Painter. So basically most of it was Illustrator, and then it was color manipulation inside of Substance Painter. Because I don't like Photoshop. Yeah, I learned Illustrator before I learned Photoshop because that was my world. And then now I have an iPad, so basically I do all character textures and everything via Procreate. So yeah. Like all of these guys are kind of done the same way. Yeah. Speaking of Substance Painter, people have showed you guys Substance Share, right? Or no? Okay. Because for a while it was like this dirty secret that nobody shared with the students, and I hated it because yeah, it's super helpful. So Substance Share, it's a free network. Like, people can upload their materials that they created or their tools, etc., and you can download and do them. Yeah, I actually do a lot of hand painting inside of Substance Painter as well. So like, let me see. I think I have it uploaded here. When I taught this one, was all hand painted inside of Substance Painter. So that one was all hand painted, and then I added in the metallics for it. But yeah. Yeah. Because I taught, this isn't my normal kind of model, but I taught modeling and rendering 1. So I was showing them a way to do that. Yeah. Yeah. But like all of these guys were done via Procreate and then pulled into Substance Painter. Or maybe not even pulled into Substance Painter. I don't remember now. Oh, good times. That was last year. Sketchfab hosted a Inktober only using 3D. And if you finished it, then you could win a year's worth of Substance Painter Premium, which I did. So, 30 days to create 30 models and all the textures to go with them. Yeah. 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 Yeah, those of you who don't use or don't look at Sketchfab, if you are a 3D artist, I do suggest it because they do contests, they do some really fun, and not just contests, because I know some people have issues with the idea of art contests and doing art for free, but they do a lot of challenges, which are just kind of, it's not so much that they don't get to keep anything generally, but they do challenges, and the challenges are a lot of fun because where did they move the actual challenge thing? Because a lot of the things are things that you would never like personally think of doing, and that's like half the fun of it. Okay, fine. All categories. Challenges. Yeah. So the challenges are really cool though here because again they're 3D, but sometimes and you get all sorts of like levels of people who do them, but they've got modeling challenges. They have texturing challenges. They have 3D scanning challenges. They have sculpting challenges. They have photo scanning challenges. They've got editor challenges, which is literally just like coming into these are a good example. This is a good example. So all it is coming into, say, oh, I don't have that one published. I should probably publish that one. Like, say, coming into this, and because the model doesn't actually have this color on it, so it's all about post-processing. So making it look like something that it doesn't look like. So adding all the bloom and adding all the extra stuff to it, which can take your model from looking really plain and not having anything on it to being really awesome. And those are really fun to compete in. And then there are some that they do, like I did this one for one, which was for a HoloViewer contest. So they've got like strict, and it's not things that I would ever like personally think to do, but to this day it's like my most popular model, and it's really calming to watch for hours and hours. So, yeah. Okay, so I have probably talked you guys' ears off. Are there any other questions, wants, desires, needs that I can help with at this moment? Okay, reminder, you have about a month for your games. We do meet on Thursday. We will talk about importing and using animations. So with all that said, have a wonderful Tuesday. You should be able to do your assignments in like the last 15-20 minutes that we have of class, quotation marks, or spend a little bit of extra time. It doesn't really matter. And I will see all of y'all who decide to attend on Thursday, and I will talk to the rest of y'all